In this sample mean problem, we're going to look at the difference between a sample of 1 versus a sample of, in this case, 50. But it should demonstrate the value of a larger sample size and what effect that has on the probability of a given result. Okay, so in this case we've got some standards for buildings for average glass thickness being called for of 0.375 inches with a standard deviation of 0.05 inches. Okay, so those are the building standards. And in the first part, part A, it says what is the probability that the glass thickness of a single window will equal or exceed 0.392 inches. Okay, so for part A that's a sample of 1. So we will still use this equation here, but the sample of 1 will just basically be dividing by the by sigma, which is our population formula. So we'll just apply that here in both cases for parts A and B. So in part A, we have z equals 0.392 minus 0.375 over 0.050 square root of 1, right? The sample of 1. So basically that just it cancels itself out there. And our result there then is 0.34. Okay, so z, our standard deviation, right, or our result, 392, right, is 0.34 standard deviations above the mean. So if we were to look at this here, right, so if the mean, it's not quite 0, but let's say we're right here, right, 0.34. Okay, and so we would then look up 0.34 in the table, and I've got a modified version of the table here, and we've got this distance here between 0 and 0.34, right, is going to be 0.1331. Okay, and we want to know what's the likelihood that they will meet or they exceed that. So fall into this area here, and so we would say 0.5 minus 0.1331 is going to be 0.3669. Okay, so that's the remainder of this area here. So the answer to part A is 0.3669 or 36.69% probability of a single pane of glass exceeding 0.392 inches. Okay, so 0.3669 is part A. Now, okay, so that's for a single sample. Now, if we have a sample of 50 that yields an average, an x-bar of 0.392 inches, right, we would then have part B, and that's going to be z equals 0.392 minus 0.375, 392 that should be, and that's going to be then 0.050 over the square root of 50. Okay, so what this is going to have the effect of doing, if we look at this, this number will become smaller, the 0.050, making this, our z value, larger in the end. Okay, and what we come up with then is 2.4. So by increasing our sample size, again, you think about spreading the mean across this larger group of windows. If that's really the mean size, that's going to be 2.4, right? So we'll say if that's 2.4, right, there's 0. We look up 2.40, and we get 0.4918. That's this area here. So we get 0.5 minus 0.4918, and that equals what? 0.0082. Okay, so I'll draw it better here. So a much smaller likelihood of that. Right, so a very small 0.0082 chance of a sample of 50 doing that. Okay, so part C brings us all together. based on our answer to Part B, if the true population for the mean thickness of glass is 0.375 inches, the 50 windows are or are not a representative sample. In this case, we would say they are not a representative sample because there's such a low likelihood of that result. If that truly were your result of 50, you would expect some sort of process issue going on there. But in this case, we would say if truly that is the case, if all the specs are right and our equipment is operating properly, a sample of 50, this sample of 50 would not be representative of our typical output.